Okay, hello. It's a long time since I did a video, and I thought I would just wing a video. I got my beer here, I got some potato chips, and I've been experimenting with something lately. So I thought I would just do a video, play around with it. I'm not sure how valuable it is yet. I haven't used it in a real project, but it's just fun to experiment with stuff, and maybe it proves to be of value. I don't know. Let's see. So this is a package I created. It's like 40 lines of code or something, but it gives some pretty awesome abilities in your code. So it's called Emmis. What was it? Proxy chain. And it's actually the nickname I have for my daughter. It's really hard to give names to packages these days. But the point here is this proxy chain thing. So this is based on proxies. And if you never heard about proxies, it's a new feature, a pretty new feature in the language that can be used for many different things. One way to use it is, for example, the Emmis library. That uses proxies to basically improve the declarativeness of Redux. Well, you can use it for anything, but this is an example of improving the declarativeness of reducers in Redux. So this is what you typically had to write. Let's see if we can see it there. This is what you typically had to write, and this is how it looks after you use Emmis. And basically what it does is use proxies to kind of like intercept how you access different properties in the state, and has immutability under the hood and structural sharing and like optimizations like that. But the point is that it helps you write cleaner code. And usually I'm working on this project called Cerebral, which also tries to help you write cleaner code. It's not only related to state changes like you saw with Redux, but it's related to expressing changes like application logic, changes to your applications, not only the state changes, but side effects and everything. So this is an example here where you see you have a lot cleaner code, and this becomes more and more valuable as the complexity of your application grows. But anyways, this proxy chain thing is here to, it's like a low entry thing to help you write more declarative code. So let's just play around with the API here. It's very simple. It's only this proxy chain thing. So if I say I want a proxy chain, and then I want to do something in my app, and I'll use a chain for that. And then I'll call this like that. So typically this will be with Redux, this would be your thunk, maybe, your thunk function. Or with MobX, it would be your action. Or in Cerebral, it will be your signal. And you just want to trigger it, that's the point. So let's move over to the application here, and like nothing happens right now. But if we take a look at this, it actually returns a promise. So let's just have a quick look at that. We'll just log directly. And when I save now, we see that it says undefined. So what we're going to do here now is that we're actually going to pass a value in here. And then we're going to call it again. And now we see that we get foo. So whatever we pass in currently is returned in this promise. But let us just start adding some methods here, like foo, bar, bas. And when I save this now, the exact same thing happens. It just passes through the value, as if these are not called at all. And actually they aren't called because this chain is a proxy. And typically you use proxies to intercept value accessing, but here we are using it to intercept methods, like a chaining API. So what we're going to do now is see how we can actually make these methods, or these operators, as I like to call them, operators, to actually do something. So instead of logging down here, we are going to create our own log up here. And this is kind of interesting because, like with Redux, you use reducers to update the state. In Emmis, you use a reducer to update the payload in the chain. So just let me show you here. So what we receive here is the payload, and then we also receive the operator. So I can switch on the operator type, and I want to return the payload by default here. And then I can say case. Okay, so if it is the log operator I'm doing something with, I want to log out the payload. And then we'll just break out of the case there. Okay, so when I save again now, we can see that it actually runs foo, just like that. So by default, Emmis doesn't have anything. You have to define whatever chaining you want, whatever makes sense for your application. So this was a really simple operator, but you can do tons of stuff here. So imagine we want to, like typically like with observables, you have map, which is really powerful. It means that you can take the current payload and return a new payload. So let's just add map here. And what we want to do is take the current payload, which is a string, and we want to uppercase, for example. Okay, and when I save this now, nothing happens because we're not actually managing the map operator. So if I case that, and then we want to return a new payload here. And what I have access to now on this operator is not only the type, but I have also access to all the arguments that are passed to it. So the first argument here is a callback. So I'll call it, give it a payload, and then currently we're just we're logging up here, so we haven't changed. We need to log again. So if I add log here, we can see that we get foo, and then we get uppercase foo, just like that. So that's how simple it is to add a map. We can try something else here. Let's delay this logging. So I want to be able to delay when I execute. And the way I can do that is because this has promises as a first-class citizen, meaning that if I want to manage delay, I can just return a new promise here. And I only need the resolve. We'll do a set timeout, and in that set timeout, we basically just want to resolve the current payload. And then the amount of time we want to wait is on the operator args 0. So if I save that, and there you see it, I can refresh. It does that thing, and then it takes 2 seconds, and then it logs out the foo there. So this is kind of cool. You actually have flow control as well. So we could do debounce here if we wanted to do that, or throttle, or whatever. Just depends on the logic you have here. But let's do something more interesting, because this is like, this doesn't give you much value. Like, typically you want some state management in your application, you want to do some HTTP requests, for example. So maybe we can try to do an HTTP request. So I have installed Axios here, Axios from Axios, and what we want to do is handle HTTP. Let's just write it out first, how we want it to work. So let's drop this delay here. And let's drop everything. And let's just do HTTP. I want to pass the method first, and then I want to pass the URL. So I have a JSON placeholder here, put that in there, and then we'll log out the response there. So let's try this out now. Do I have pretty format? No. Maybe it's, oh yeah, it's such a small screen, so yeah. Anyways, HTTP, and what I want to do is, let's just be explicit here and say method is operator args0, URL is operator args1, and we want to use the method and call it with the URL, like that. So now I run the chain, and as you can see, I'm receiving some data here, headers and everything. So maybe I rather want to only have response data. Let's save that. And now we have the post here. So that's kind of nice. But typically something can go wrong with your request. So how can we handle that? How can we express success and error? So what we're going to do here is actually add a third argument. Because typically with observables, you would have like another operator to catch and stuff like that. And to me, that has always been a bit weird. It doesn't feel natural to me to express conditionals that way. So what we can do here is rather give a third argument, which is an object, and this is going to have a success and an error property. And they are actually going to take their own chains. So let's see, we have error and success there. So what we need to do up here is to add these paths, args operator args2. And what we'll do here, instead of returning response data, we'll rather say path success, and then we'll call that. Then we're calling that chain with the data, and then on catch we'll path error. Then we'll call it with the error. Let's see if I can format. Still can't format. Anyways, doesn't matter. Okay, so what you can see here is that I still get the normal value here, and that is because I'm not doing anything. So maybe we can use the map here. We can map out the body, for example. So if it's a success, I want to map, and now we have the post here. So I want to map out the post body. When I say that now, you see that that's what I actually get when I log out. And I can even, like, let's delay this for 3 seconds. And then, well, maybe I should log first so you can see that it's actually, let's clear out and log there. Foo does the request. And then, yeah, maybe this wasn't the best, best example. Let's log out before. Let's do it like this instead. So we got it, takes 2 seconds, it maps to the body, just like that. So the cool thing is that you can very easily compose these things together. And again, you just do what makes sense for your application. There's no hard-coded API here, and I think that's important because people think about logic differently, and applications are different. So there are tons of operators that you don't need. They're so, as you can see, they're so easy to define them. So I think it's more fun as well. Like you decide, like you create your own API for your application, an API that makes sense for you. You just have a tool that forces you into this declarative way of doing it. And you have it gives you the composability just out of the box. So okay, let's play around with this was like a side effect, like a typical side effect in an application. Let's play around with state management. So let's import Baobab. So let's search it up here. Baobab Like, this was the first project where I felt I could do complex state management in applications. It's just an awesome project. What it does is it's a single state tree, and it allows you to create cursors into that tree so you can listen to changes. So what we're going to do is that we're going to create, let's imagine that we have created our application and we have our baobab. We have our baobab tree with some state foobar. What we want to do is expose this state tool to our chain. We can do this in many different ways. I'm just going to show an example, and that is to use, I'm just going to expose set, because what you would do here in the tree, you would say tree set, then you give it the path, which is foo, and then you would say bar2, for example. So we are going to expose that set. And we're not going to change the payload here, so we just break out of it. But what we're going to do is point to tree, and we are going to set, and we are going to expect that we get the path on as the first arg, and then we are going to get the value as the second argument. Okay, and what I also want to add here is the ability to log the state. So let's create that, console.log tree.get. I believe that's it. Okay, let's clean up a little bit here. Yeah, we can drop this HTTP request. Let's rather log the state. Let's do a set on foo to bar2, and then we'll log the state again, just to see if it actually changes. I say that, and it does. So that's pretty neat that that we can do that. What's also really cool here is that I could intercept this. So I could pass this information, for example, to a debugger if I wanted to do that, or just log out the change so that I could track it or whatever. So that's that one. But what if you wanted to actually access the payload here? Now, there's really, or you wanted to access the existing state. This is kind of like the problems you get when you look at observables, because observables are so isolated. You can't just grab state from somewhere or stuff like that. So, but here we can choose how to expose it. So what I want to do is, if, let's see here, let's try to write this as clean as possible. If type of args1 is a function, then I actually want to call that function, and I want to give it the payload, and I want to give it the get, and I want to give it the existing state. If not, I just want to give it the value on operator args, like that. So now it runs exactly the same way. But if I give this a function instead, I could say, let's say payload, and I would then want to point to payload. Yeah, I just want to use the payload. So if I change this to 123, for example, run it again. Oh, there, okay, there we go, bar, and then 123. Or we could say that, okay, I want to use the state foo to uppercase, for example. And now it's uppercase. So as you can see, you can just create it the way it makes sense to you. And then you have this chaining API that can do whatever you want for your application. And what I mean about improving declarativeness is that we could now make this even more declarative, because it's functional. So if I want to, for example, let's give this an underscore because we're not using it. I could say uppercase uppercase foo, for example, uppercase foo. And now we suddenly have this really clean small function that is easy to test if you want to do that, and it cleans up your code as well. As you can see, it does the exact same thing. So I think this is pretty cool. Okay, so now we have done some state management. Let's okay. Let's see how you would do this with Redux. So let's change it out with Redux, and we'll bring in create store, and let's create the store. So the store here will be create store, and then we give it a reducer which has the state, and we'll just do it very simply here. We'll give it an array and we get the action. And by default we return the state and we switch on the action type, and if the case is add to do, what we want to do is return the current state and we concatenate the new to do like that. Now it's starting to break here because we shouldn't have that set anymore. Can remove that. Log state should now be store get state instead. Yeah, it's an empty array now, so that's good. Okay, so what we want to do is instead of set, we want to dispatch add to do. So let's write that. It's a case. What was it? Dispatch. And again, we don't want to do anything about the payload, so we'll just break. And what we'll do is say store dispatch and then operator args0. And maybe we just want to give it the payload by default. So what's happening now is that let's see what happens now. Oh, yeah, sorry. The way you dispatch is type, and that's type, and then you have payload. Sorry. Like that. That's the signature. Okay, so now we actually push the 1, 2, 3 into that array. But what we really wanted here was to actually create, let's call it add to do instead. Add to do, and give it a title like drink more beer. And what we can do now is, well, we can use our current map method. So let's map the title into title and completed false. Save that. Now we have an array with a to-do in there. But you might not want to do it like this. Maybe you want to create the payload for the action on the dispatch here. So let's do that. Let's move this thing here and let's put it in here instead, much like we did before. But then we have to make sure that when we're going to add the payload here, we have to again check if type of operator args1 is a function, because if it is, we want to call it. Let's move it into a variable. Dispatch payload operator args. Well, that wasn't much shorter. Call it d payload. So if d payload is a function, we want to call it with the payload of the chain, or we'll just give the payload. So if I save that now, and let's refresh, we see that I do get it in here as normal again. Yeah, so that's like like now we went through 2 different state stores. We did Ajax stuff. It's very easy to get into it, I think. And to me, like, I've been working with this for a day, maybe 2, yeah, 1 full day, and it's hard to say how much value it can give, but just playing around with it like this, it seems to be very powerful. And again, it's not like writing normal imperative code is bad, but I think when you're forced into a chaining API, you, just like with observables and filter, reduce, and map in plain JavaScript, you write better code because you kind of like hand it to you all the time, like, maybe you should make this its own function. Again, we can say create to do from title here, create to do from title, and now we have a tiny little function for that. And at the same time, we improve the declarativeness of our chain. Yeah, so I think that just that small concept is really powerful. Okay, but we have to talk about one more thing, and that is Typescript. So it's actually written in Typescript, and that's what I spent most of my time on, trying to, god damn, I hate Typescript sometimes. Like, JavaScript is so dynamic and can do amazing things. And then when you, like with this thing, it's super dynamic, but it seems very powerful, and then you have to battle TypeScript to kind of like prove yourself to TypeScript or something. It's really annoying. But anyways, TypeScript is super valuable when it works. So let's just do this from the start, I think. And we'll just do some simple examples. Let's see here. First of all, we have to change this to TS. We have to. I'm using Parcel.js, by the way, here. It's just amazing. I think we need to restart when we change the entry point. Okay, so I think we're good. So what we're going to do now is actually, let's just create a chain first. Proxy chain. And hopefully I'll remember all the typing here. And then we'll do something. And then we call that do something. Okay, again, nothing happens. So let's do this. Maybe we should just do the mapping. Okay, so I'll need to import iProxy chain here. And we're going to create an interface of, let's just call it chain. And we're actually going to take an input and then an initial, which we'll say can equal to input. And then we're going to extend iProxy chain like that. And we are, as no export member, oh, then that fails miserably. Okay, there we go. Okay, I'll have to fix that. Anyways, so what happens now is that, let's fix all of this. So now it says that the payload has to be a string, and if I change the number, it will say that this won't work because I have defined the chain as a string. So I'll give it that one, and then we also have title here. It says it's a string, so we can do uppercase on it, and let's just log out. Oh yeah, we didn't do the log. So log is, well, it's nothing really. And then it just moves to a new chain where we have the input and initial. Okay, so now we didn't do anything, so we just passed the current input and the initial. So now we can log, and now we actually have to write the, let's say, operator switch operator type. And now if I say foo here, it will say that this is not the type you have put up here, so I have to say map. Oh, sorry, case. If this is foo, it should break, yeah. So it maps, it types that stuff, and then let's return operator arg0, call that with payload, and then we have case log, and we'll console.log payload and break out, and then we'll return payload. Okay, so now we get, yeah, 1, 2, 3, let's use foo instead, and uppercase foo. Okay, so I just wanted to quickly show you how the types work. So basically you extend the iProxy chain, and you have to map out this part. This is the same for everyone. And then whenever you create an operator, you just have to handle like where is the input, like the payload, if any. Maybe you have some state types related, like whatever you need, and then the output should always be a new chain where either you pass in the current input here because it's the same, you haven't done anything to the payload, or you have to use a generic to define what's the output. So what we could do here is we could say that this rather becomes a number, and then when we hold over here, I guess, yeah, it says number now. So maybe we can map again here. Let's just number. So now it says number. So it does this typing. So if you would compose in a function, some function. Sorry to jump around here, but I hope this makes some sense. And I would say that I want this arg to be a string, and I want to do arg to uppercase. It will yell at you because now it's a number. So you get a lot of help here, and you only have to worry about this input and initial. And you should have everything you need to do some pretty complex typing on your operators. I tried like doing some crazy stuff. Yeah, but okay. I hope this made some sense. And yeah, I'm definitely going to try to use this as soon as I get a chance. But yeah, please try it out. Or I hope it gave you something. But thanks for watching, and have a good day.